Hello viewers, welcome to my channel. I'm Hasham. So now I'm going to start the problems on set theory. Last two videos I have explained you in detail regarding the meaning of the term set, the elements of set, representation of set by roster model and also by set builder model. I have explained in detail, and then I have explained you about different types of sets like null set, like singleton set, finite set, infinite set, equality of sets, equivalent sets, proper set, subset. All these concepts I have explained in the previous video. Apart from that, set operations, the set operations like union of set, intersection of sets, and all these things I have explained in detail. If you have watched that video, then you can easily understand the problems. So the problems are completely based on the conceptual clarity. So don't ignore the theoretical part and directly come to this practical part. You cannot be able to understand. So if you want the complete command on the subject, on the topic of set theory, watch once or twice the first two videos. Then you can come to this video. You can be able to enjoy learning this set theory. So now I'm going to start the problems on set theory. So before starting the problem, as usual, I expect my viewers to have a printout of the problems which I have given in the link under my description. So keep ready the problems and start watching the video. Now I'm reading out the first problem on set theory. State whether the following. See here, for our convenient learning, I have divided the complete topic of set theory into three exercises. Exercise 1A, 1B, 1C. The first exercise 1A, first problem I am reading out. State whether the following are well-defined sets. So three separate statements are given. Now we have to explain. No calculation, nothing. Simply you have to give the explanation whether it is a set or not. What is the meaning of the term set? A set is a well-defined class or classification of object. A well-defined class or classification of a set of objects, that is called set. Now we can say whether an element belongs to the set or not. That is the main purpose of learning the set. Now here three statements are given. We have to decide whether it is a set or not. First, A, the number of students in your class. Can you make a set of the number of students in your class? Normally the class will have finite number of students. We don't have a class which have infinite number of students. Normally we have finite. So we can make a set. We can make a set for the number of students in the class. The first answer, yes, of course. The students in a class can be made a set. Second, the batsman who scored a century in the World Cup 2015. Yes, of course, because we have limited number of batsmen who scored a century in the World Cup. So we can put in bracket who are the batsmen who have scored century in the World Cup. Set can be formed. Third, happy people in Hyderabad. Happy people in Hyderabad. Happiness cannot be measured. It's a subjective term. Happiness is a thing which we can feel, but we cannot measure it. We cannot count happiness. So happiness is a subjective item. We cannot put it in a set. We don't know how many people are happy, how many people are not happy, how many people are full happy, how many people are partly happy, how many people are not at all happy. We cannot, because it's a subjective term. So we cannot make a set of this happiness, happy people in Hyderabad. So that is our answer. Already I have explained you. Whatever I have given the explanation, you have to put it on a paper. Writing the answer. Right. Exercise 1A. While we can clearly identify whether a student belongs to a class, whether a student belongs to a class or not, we can identify. So we can make a set of the number of students in a class. Or whether a batsman has scored a century, it cannot. Whether a batsman has scored a century, we can put it, we can count it. We can say whether this batsman will come in this set or not, because he has scored the century or not. If he has scored the century, he can be put in the bracket. If he has not scored a century, we cannot include it in the set. So easily we can make a set for those people who scored century in the World Cup. it cannot be ascertained with certainty as to who is happy. We cannot measure, we don't have any standard or norm to measure the happiness. The happiness is a subjective. It will differ from person to person. It differs from person to person. So we cannot say who is happy, who is not happy. So we cannot make a set of the happy people. So therefore, A, that means the number of students in a class, it is a set. B, number of batsmen who scored century in the World Cup, yes, it is a set. But C, how many people in Hyderabad are happy, it is not a set, because we cannot measure happiness. That's it. First problem completed. Now I am coming to the second problem. Represent the following in roster form. Two types of representation are there. Roster form set and secondly set builder set or rule based set. So first of all, roster form. Roster form set is a set in which we list down all the elements in bracket. All the elements of set in a bracket in roster form. So same problem here. We have to put the set in a roster form. V is equal to A point, A, B, C, D, E. 5 sub questions are given. First I am reading off first question. V. V is equal to vowels in English. We know the vowels in English are A, E, I, O, U. That's all. A, E, I, O, U. These are called the vowels in English language. So it is asking you to make a set, roster form of set, giving the list of vowels. So very easily we can write. See 2A. V is equal to all vowels in English. The vowels in English are A, E, I, O, U. These are the 5 vowels. The roster form of V is equal to in bracket. In bracket I am writing down all the elements. The elements are vowels A, E, I, O, U. That's it. Over. Second, B point. P is equal to all prime numbers below 10. All prime numbers below 10. So P is equal to all prime numbers below 10. The prime numbers below 10 are 2, 3, 5, 7. First of all, you must know what do you mean by prime number. A prime number is a number which is divisible by 1 or divisible by itself. Divisible by 1 or divisible by itself. That is called prime number. So we want the prime numbers from 1 to 10. Between 10 up to 10. How many prime numbers are there? A number which is divisible by itself or a number which is divisible by 1. So 2, 3, 5, 7 are the prime numbers. Why 2 is a prime number? Because 2 is divisible by 1 and 2 is divisible by 2. No other number is divisible by 2. That means 2 is divisible by itself or 2 is divisible by 1. Similarly, 3. 3 is also a prime number because 3 is divisible by 1 and also 3 is divisible by 3. No other number is divisible by 3. Similarly, 5. 4 is divisible. 4 is not a prime number. Why 4 is not a prime number? Because 4 is divisible by 1. 4 is divisible by 4. 4 is also divisible by 2. Apart from itself, apart from 1, it is also divisible by 2. So 4 is not a prime number. Then 5. 5 is a prime number because 5 is divisible by 1 and 5 is divisible by 5. No other number 5 is divisible. So 5 is a prime number. 6. 6 is not a prime number. Why? Because 6 is divisible by 1. 6 is divisible by 6. 6 is also divisible by 2. 6 is also divisible by 2. 6 is also divisible by 3. That means apart from 1 and itself, it is divisible by other numbers also. So 6 is not a prime number. 7. 7 is a prime number because 7 is divisible by 1 and 7 is divisible by 7. No other number is divisible by 7. No other number. That means no other table 7 is there which is divisible. Then 8. We'll check. 7 is a prime number. 8 is not a prime number because 8 is divisible by 1. 8 is divisible by itself. 8 is also divisible by 2. 8 is also divisible by 4. So 8 cannot be said a prime number. 9. 9 is also not a prime number because 9 is divisible by 1. 9 is divisible by 9 9 is divisible by 3. 9 is also divisible by 3. So we cannot say 9 is a prime number. 9 is not a prime number. Then 10. 10 is also not a prime number because 10 is divisible by 1. 10 is divisible by 10. 10 is divisible by 2. 10 is divisible by 5. So in this case 10 is divisible not only by itself, not only by 1, but also it is divisible by 2, it is divisible by 5. So 10 is not a prime number. So what is our question? All prime numbers below 10 it is saying. Below 10. So below 10 prime numbers are 2, 3, 5, 7. Here expression also I have given. Prime numbers are those numbers which are divisible by 1 and divisible by itself. That is, they don't have any other factor other than 1 and itself. So prime numbers are 2, 3, 5, 7 in bracket. That's it. Now C. What is the C bit? O. O is equal to, O is the set. The elements are all odd numbers. All odd numbers. So here odd numbers are 1, 3, 5, 7, 9, 11, etc. So these are called odd numbers. The roster form of odd numbers are O is equal to 1, 3, 5, 7, 9 up to infinity. This set is an infinite set. There is no limit of odd numbers. It can go up to infinity. So 1, 3, 5, 7, these are the elements of set O. D point. E. E is equal to all letters in the word mathematics. All letters in the word mathematics. So here I am writing on E is equal to all letters in the word mathematics. In a set, the elements must never be repeated. In the word mathematics, you can see many alphabets are repeated. Example, M is occurring twice. A is occurring twice. Similarly, yes, M and A both are occurring twice. So in a set, the alphabet should not be repeated. Only once we should take. Only once we should take. And it is better to write the alphabets in order also. In a set, the elements must never be repeated and must be written order-wise. Roster form of A, E. Roster form of E. E is the set name. And first, what is the first alphabet? A. A is occurring twice, but we will write on only once. After A, B. B is not there. B is not there. Then we come to C. C is occurring only once. We will take one. After C, D. D is not there. E. E is there only once. After E, F. F is not there. G is not there. H is there. So we'll take H. I. I is there. J is not there. K. K is not there. L. Not there. M. M is there. N. N is not there. O. O is not there. P. P is not there. Q. Not there. R. Not there. S. S is there. After S, T. T is there. U, V, W, X, Y, Z, not there. So we have written the elements as A, C, E, H, I, M, S, T. These are the elements of the set E. So we have written the elements of the word mathematics in this. Next, M is equal to, last E sub question. M is equal to all multiples of 3 below 20. All the multiples of 3 below 20. That means you have to remember the 3 table. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21. But 21 we should not go. It is asking you below 20. So up to 18. Up to 18. So multiples of 3. M is equal to all multiples of 3 below 20. The multiples of 3 are below 20 are 3, 6, 9, 12, 15, 18. The roster form of M is equal to M 3, 6, 9, 12, 15, 18. It's a finite set. It's a finite set. That's all. So all the E bits we have completed. Second problem we have done. Now I am coming to the third problem. Problem number 3. Represent the following in set builder form. This is a second method of representing the set. Set builder form. This is the form in which we write the property of the elements. The property of the set which is shared by all the elements. The property of the set which is shared by all the elements. That is called set builder form. So here A. The elements are given. The elements are 2, 4, 6, 8. Now we have to put this set in a rule method, in a set builder form. So if you observe, the numbers 2, 4, 6, 8, etc. are even numbers. 2, 4, 6, 8, etc. are all even numbers. So we can write the set in a rule form. X, this is the element x. Element x such that x is an even number. That means the set has an element x. We are not given the name of the set. Set name is not given. But the set has the elements x. And element x is an even number. Element x is an even number. So we have written the rule in the bracket. What is that rule? X is that element such that x is an even number. That's it. First bit over. Second bit, 4, 8, 12, 16, 92, 96, 100. 4, 8, 12, 16. If you closely watch these numbers, all these are multiples of 4. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. All are multiples of 4. Multiples of 4. So we can write 4 into 1, 4. 4 into 2, 8. 4 into 3, 12. 4 into 4, 16. Every time we are multiplying 4 with n natural number. But the limit is, it is going up to 100. That means n into 25. If you take 4 into 25, if you take n 25, up to 25 if we go, so 4 into 25 will be 100. So we are not going beyond 100. Our limit is up to 100. So how we can represent the set? The numbers 4, 8, 12, 16 are all multiples of 4. 4 is equal to 4 into 1. 8 is equal to 4 into 2. 12 is equal to 4 into 3. 16 is equal to 4 into 4, etc. We can see all are multiples of 4. However, the set is finite. It is ending with 100, which is 4 into 25. See, it's a finite set because the limit is given. The set is going up to 100. Up to 100 means 4 into 25. That means the n maximum value is 25. When we take n is equal to 25, then 4 into 25 will be 100. We have to go up to n is equal to 25. So thus the set will be, the set has x an element. X is an element of that set such that x is equal to 4n. X is equal to 4n. N stands for natural numbers. The natural numbers are 1, 2, 3, 4, etc. up to infinity. It can go up to infinity. So n belongs to n, natural number. Small n belongs to natural numbers. Capital N stands for natural number. Capital N is a symbol for natural number. And natural numbers are 1, 2, 3, 4 up to infinity. Positive numbers. So here this n belongs to natural numbers. Natural numbers are 1, 2, 3, 4. And one more condition, n is less than or equal to 25. That means our n value should not exceed 25. It should go up to 25 because 4 into 25 will be 100. And it is given in the problem, we have to go up to 100, not beyond 100. So not beyond 100 means n should not be more than 25. N should be up to 25 or less than 25. So the rule is, a set which consists of x an element where x is equal to 4n. This is the condition. X is equal to 4n where n belongs to natural numbers. N belongs to natural numbers. Then n is less than or equal to 25. N is not exceeding 25. That's it. This is the rule. Next comes C bit. 5, 25, 125, 625. Now if you closely observe these numbers, easily we can find out 5. Then 5 to the power of 1. 5 to the power of 1 is 5 only. 5 to the power of 2, 5 square, 5 into 5, 25. 25. Then 5 cube. So 5 to the power of 1 is 5. 5 to the power of 2 is 25. 5 to the power of 3, 5 into 5 into 5. 5 5s are 25, 25 5s are 125. So 125 we are given. Then 5 to the power of 4. 5 into 5 into 5 into 5. 4 times. If you multiply 5 into 5, 25. 25 into 5, 125. 125 into 5, 625. So here it is given 625. So we can think about the rule. What is the rule? 5 to the power of n. N stands for natural number. 5 to the power of n. N belongs to natural number. N belongs to natural number. It will be 1, 2, 3, 4, like that it goes on. It's an infinite set. There is no limit of the set. There is no limit of the set. So it is an infinite set. The rule is the set has x as an element such that x is equal to 5 to the power of n. And n belongs to natural number. N belongs to natural number. So here I have written 5, 25, 125, 625. 5 is equal to 5 to the power of 1. 25 is equal to 5 square. 125 is equal to 5 cube. 625 is equal to 5 to the power of 4. In all these cases, base is 5. And the powers are 1, 2, 3, 4 like that. So the set is infinite. Thus the set is x. X is an element of set such that x is equal to 5 to the power of n. And n belongs to natural numbers. That's it. So we have completed third problem. Now see the fourth problem. List the elements of the following sets. List the elements in the following sets. First one, X is a set where small x is the element such that X belongs to natural number. This sign is given here. This sign represents belongs to. This sign represents belongs to. Whenever this sign comes, you should mean belongs to. So here it is given x belongs to natural numbers. That means the elements are all natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6 up to infinity. So here the answer. A, x is equal to small x. This is an element such that x belongs to n. This sign belongs to. It is read as in the set x. Small x is an element such that small x belong to all natural numbers. All natural numbers. That's it. Next, second. X is equal to, capital X is the name of the set. Small x is the element such that x belongs to natural number and 1 is less than small x is less than 5. Yeah, but one more condition is given. One more condition is given. The element small x is less than 1 and x is less than 5. X is equal to small x colon x belongs to natural number, 1 is less than x, x is less than 5. So how to read this set rule? How to read this set rule? It is read as in the set x, small x is an element. This small x is an element such that x belongs to natural number. Capital N stands for natural number. That means x, an element, is a natural number. And x always lies between 1 and 5. One more condition, restriction is given. The element lies between 1 and 5. It is given 1 is less than x and x is less than 5. That means x lies between 1 and 5. So between 1 and 5. What are the natural numbers between 1 and 5? 2, 3, 4. Between 1 and 5 it is saying. So between 1 and 5, 2, 3, 4. So x is equal to 2, 3, 4. These are the elements. That's it. That is the meaning of this rule. Next, C point. X, the name of the set is capital X, is equal to small x element such that X is an alphabet in English language. The element X is an alphabet in English language. What are the alphabets in English language? A, B, C, D, E, F, G, H up to Z. Up to Z. So these are the English alphabets. So X is equal to X such that X is an alphabet in English language. X is an element of capital X such that X is an alphabet of English language. So X is equal to A, B, C, D, E, F, G, H up to Z. All these are the elements of X. That is the meaning of this rule. Next, D, last question. X is equal to small x is an element such that x is equal to 2n, where n belongs to natural number. N belongs to natural number. Natural numbers are 1, 2, 3, 4. So how we can write this set x is equal to small x such that x is equal to 2n. And in place of n we'll write on 1, 2, 3, 4. 2 into n. 2 into 1, 2. 2 into 2, 4. 2 into 3, 6. 2 into 4, 8. 2 into 5, 10. Like that it goes on up to infinity. So the set will be like this. X is an element of set x such that x is a multiple of 2. X is a multiple of 2. X takes different values for different values of n. That means small x will take different values depending on the values of n. When we take n is equal to 1, then x is equal to 2. When we take x is equal to 2, then n is equal to 2. If we take n is equal to 2, this x will become 4. If we take n is equal to 3, x will become 6. Like that, the value of x element will change as the value of n changes. That's it. So these are the 4 problems, starting 4 problems I have explained you regarding the set theory. So if you take the interest in watching carefully with full concentration, with full focus, definitely you can enjoy learning. So don't think only from examination point of view. Think about gaining the knowledge. Can you be able to understand or not? Watch the video once and twice or thrice. Definitely you can get a lot of command. So if you are satisfied with my lecture, give a like to the video. Share my channel in your group, in your friend circle, so that more students can watch the video and enhance the knowledge, get the command on the subject, be successful in life. And give your comments on these videos. Lastly, don't forget to subscribe my channel if you have not yet subscribed. We'll continue the next problem in the next video.